So the purpose of creating a confidence interval is to estimate the mean of a population using the mean of a sample. And the idea behind it is that when you randomly select a sample, the mean of the sample is likely to be somewhere near the mean of the population. In other words, the population mean is usually only so far away from the sample mean. So when you take the sample mean and you add and subtract a number to the sample mean, and you create an interval around the sample mean, you'll usually be able to capture the population mean inside of the interval because the sample mean and population mean are usually close to each other. But when you create a confidence interval, the confidence interval doesn't always include the population mean, because remember that if you do end up getting an extreme sample, meaning if you do end up getting a sample that's has a sample mean far away from the population mean, then the confidence interval won't include the population mean. Remember, the population mean is at the center of the sampling distribution, and if you're creating a 90% confidence interval, you have to get a sample that's inside the middle 90% in order for the confidence interval to work and for it to capture the population mean. If you end up getting a sample mean that's so far below the population mean that it's in the lower tail down here, then the entire confidence interval will fall below the population mean. And if you end up getting a sample mean that's so far above the population mean that the sample is in the upper tail, then the entire confidence interval will fall above the population mean. But the good news is that if you randomly select a sample from a population, you have a good chance or a high probability of getting a sample from the middle area, and you have a much lower probability of getting a sample from the tails. Which means that when you randomly select a sample, you have a high probability of getting a sample from the center area, which is what you want because you need to get a sample from the center area in order for the confidence interval to include the population mean. And actually, if a person created 100 different confidence intervals, meaning if a person randomly selected 100 different samples from the population and created a 90% confidence interval with each one. So if the person is creating 100 different 90% confidence intervals, the person would expect 90% of them to capture the population mean, meaning the person would expect 90 out of the 100 samples to fall in this middle area, and the person would only expect 10 out of the 100 samples to end up being samples from the tails that give you incorrect confidence intervals that don't include the population mean. So, and if the person